This is James Ball of the Hacking Beavers group. In the last video, I displayed several new cheats our group has integrated into our trainer. I demonstrated these cheats being implemented with a GUI, and I expressed my hope that we would be able to create an internal hack rather than an external one. As before, I'll start off with the group efforts and then get into the work I've done personally. Let's start with the internal hack. First of all, it's here and it's working. Note that the mechanics of the cheat are largely the same, and it's the architecture of the hack that has been reworked. You can see that instead of searching for a target process running on Windows and acquiring permissions from the kernel, the internal hack is activated by injecting a dynamic linked library into a user-specified process. This yields direct access to the process memory. There are several benefits of this method of game hacking compared to our previous one. First, it's harder for anti-cheat software to detect. One common method of blocking cheats is to outright prevent the user from creating handles using object register callbacks. Remember that a handle is required in an external hack to read and write to process memory. Secondly, by directly interacting with the process memory via injection, our cheat should also be faster and have a smaller impact on the game's performance. Finally, and most relevant to our needs, an internal hack has much more potential in terms of what it allows the attacker to do. You can see over here that we're starting to use DirectX tools. There's no more Qt. I can't say I'm excited about abandoning all that I learned with that other tool, but that's part of doing a project of this size. Just as a proof of concept, I've got my mana running. I can change my health and turn off the game, all from the in-game in-window menu. Alright, the internal hack is implemented. Once we add the other cheats from before, are we done? No, not at all. This is only week 8. So let's take a simplified look at what these hacks are doing. Remember altering the mana value with Cheat Engine from way back when? This is accomplished by looking for these values stored at addresses in dynamic memory and then overriding those values. It's relatively simple and we can use it for more than just Pwn Adventure. I've used this to alter gold in Baldur's Gate, character stats in Outer Worlds, ammunition in Assault Cube, and more. For over a month now, finding reliable, repeatedly available paths to values like jump height, walk speed, this has been the primary challenge and objective of our efforts, but there's a lot more we can do. One of the first enemies you encounter is the bear. These bears have about 125 health and take a number of fireballs in order to drop. From experience, I know that the bear files are located in GameLogic DLL. And so as we look through the assembly code here in the function bear initiate, through experimentation, we found that this command right here, this move command, moves the 7D value, 125, into this register, which represents the bear's health. Now, what happens if we go in here and we change this from 125 to, let's say, 2? Let's go back in the game and see what happens. So we're going to run back. I think we've gone far enough away that the bears have despawned, and hopefully we're going to initiate a respawn here. Hey, look, that bear is a lot weaker. He has 2 health now. Potential here is huge. By rewriting the assembly code in the game's logic, we can change the very mechanics of the game, not just values. For example, our mana hack currently does a while loop and sleeps for a bit, goes back through and double checks and overwrites the mana address with a new value. So instead of doing that, maybe we could just go into the assembly code and replace the line that subtracts mana with a no-op. We could also change the apply damage function to check if our player is the object being passed, and if so, we can skip the part where damage is applied. Maybe we could alter the starting weapon, Fireball, to have almost no cooldown. So this is where I'll be focusing my effort in the upcoming week. I'm going to alter the game's assembly code by creating a hook. Now the way a hook generally works is by injecting a jump at the beginning of the block that you're targeting. This takes you down to an area where you've injected your own code. That's run, and then at the end of it, another jump takes you back to the block that you were targeting. This way the code's flow is not interrupted. So the way I'll be finding the location in which I want to inject my hook is by finding the address in which those instructions exist in memory. I'll attach my debugger to Pony Island Adventure, go to the target location. In that byte sequence, C74730, the double word 2, and then the 85F6, that byte sequence is unique in memory, so when our hook goes looking for the byte sequence, we know it's going to find the area that we want it to. Finally, I want to both thank and cite my group members Brock and Shao, as well as users Rake and IceWolf at the Guided Hacking forums.